Hello, and welcome to the seemingly never-ending series Game Revolutions, episode 830. Perhaps this is going on for so long because I do stuff like I'm doing today, taking an idea that I have already explored ad nauseum and adding more nauseum. In a previous episode, I went through several iterations to get the gravel scrolling as fast as I could in response to a clever YouTube viewer comment. Today's episode is completely inspired by viewers just like you. I've gotten some more ideas about how to scroll the gravel even faster. Will any of them actually scroll it faster? Who will reign the champion fastest gravel scroller? As a reminder, here is the current version of this routine. This, as you may recall, just rotates the gravel to the left, although rotate is no longer the right word to use. It scrolls it to the left and then feeds into the right from a buffer. We do it 2 bytes at a time, so whatever is at offset 2 goes to offset 0, whatever is at offset 4 goes to offset 2, and so on, all the way down the line, until we take whatever the final 2 bytes are and we move them 2 bytes to the left. And then we have some code here to feed the right side of the gravel from wherever this thing is pointing, and that's it. Thanks to Curtis, who commented that maybe I would gain some cycles by doing partial stack blasting, where I use the U register to get my bytes with a pull, and then I just do a bunch of stores using offsets from U, and then I do another pull and another pull. This way I don't have to readjust U during the whole process. You'll notice there are no pushes. I'm doing stores instead of pushes, and that just keeps things kind of simple and reduces my reliance on the other registers. This part of the code I only had to change very minimally. I just changed which registers I was using and what the offset was at one place, but it's basically the same. This is the part that was changed rather significantly with Curtis's suggestion. Curtis's idea uses U as the pointer where we copy our bytes from, and we're copying now 6 bytes at a time. So we start U off 2 bytes into the gravel. So U is pointing 2 bytes from the left, and we grab 6 bytes from there, and we copy them 2 bytes to the left. Now this can be a bit tricky because U is changing from this instruction, but if you follow it along, you'll see that the original U points to an offset of 2 from the left. So we're grabbing the words from offset 2, offset 4, offset 6, and the very nature of grabbing those bytes will shift U past that word. So now U is at an offset of 8 from the left side of the ground. So we'll take that leftmost word and we'll put it at -8 offset from the current U. -8 offset from the current U is 0. So we move it into 0, -6 brings us here, and -4 brings us here. So the bytes from these 3 starting points now go to these 3 starting points. And once you understand that, you understand the rest. U keeps moving along, so I don't have to adjust U at all. I just grab the next 3 words, and I use the same offsets because now U is pushed past those words. And I keep on doing this until I'm all done. And then here, basically the same code I had before to feed gravel from the right. The only difference is where I put that gravel. So I already have U pointing just past the right word, so I just offset -2 from U, and I store the new word there. Otherwise, it's the same. And how do the cycle counts compare? Here's the old version starting here. So I have the totals calculated for me by LWASM. Since there are no loops, I don't have to do any hand waving. So we end up at 251 cycles, including the RTS at the end. That's the old code, 251. Here's the new version, Again, starting with loading register to point to the graphics area. Boop, 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 boop. And then that part of code at the end. And now 221 as compared with 251. That's a good 30 cycles that I just saved by reading a comment. Thank you, Curtis. Shortly after this suggestion, Paranoid Cactus Games came up with their own suggestion. They provided code that did full-on stack blasting, using every register known to mankind. But there's a price to be paid. Manual adjustments had to be made to you after every single pull and push. Also, in order to stay clean, I'm going to have to tuck away the condition code and DP registers beforehand, and I'm going to need to store the S register beforehand. Will this gain me anything? So first up, I am tucking away my DP and CC. Next up, I'm tucking away my S. One of the things I liked about this code, which I hadn't considered doing before, is he's using self-modifying code to tuck away S so that later, when we restore it, we can use immediate addressing. That'll save us 3 cycles from 7 down to 4 when we do that load. Alright, so we load our U at the beginning of the graphics buffer. We adjust U to be 2 bytes into it so that we're ready to copy the first word, or I should say the first 10 bytes. So we have a series of pulls, adjust, push, adjust, pull, adjust, push, adjust, and we do that 3 times. So we start off with U at an offset of 2, and so the 10 bytes it's going to grab will be shifted to the left by 2 bytes. So we're going to fill these registers with those bytes from those offsets. And so that means our U is now pointing here. So this first adjustment to move U2 to the left will shift U here. And that means that when we start pushing, U starting here will first shift to the left and then we'll push. So that means this S, which was at offset 11, will now be pushed here to offset 9. So these registers will now be pushed here. And that also means the U will end up here at 0. So to prepare for the next pull push, we need to add 12 to U so that U is here. And then we'll start grabbing the bytes from 12 and on so that we can push them to 10 and on. After we do that 3 times, we've basically gotten everything done except for the final word. So we restore our stack, we take care of the final word, and again, I didn't have to change this code much, but I did have to change the offset to U where I put that final word. And then when I'm done, I can combine the restore of the CC and DP register with the return. How does this measure up? Recall that with Curtis's improved code, we were down to only 221 cycles. Will the extra overhead of this new approach ruin everything? Not at all. We're at now 208. We have saved even more cycles. Woohoo! It is at the expense of some readability, but you know, you debug this once, you get this working once, and you're good to go. So I'm inclined to stick with this. Or so I thought, until Steve messaged me this on Discord. Steve was thinking way outside the box and had an interesting idea. Why do you need 32 bytes of gravel? Can't you just do 8 bytes of gravel and then repeat that 4 times? If you do that, you can do full-on stack blasting without needing to use the dangerous registers and without needing to do much adjustment at all. Steve's idea is also a radical departure from everything I had been doing and what the other folks had been doing to improve upon what I had been doing. So all of us have been scrolling the on-screen bytes. We were making use of the fact that the source bytes are very close to where they need to be in the destination, just an offset of 2. So we're using the off-screen buffer both as our source and as our destination. And only at the end do I use a separate buffer of graphics bytes to feed the right side of the off-screen buffer so it's ready to scroll next time. Steve's idea goes back to the very old way I was doing this, where all of my source bytes remained in a separate buffer, and every time you go to draw the ground, you always take the full bytes from that separate buffer and copy them from left to right into the off-screen buffer. The key point is, the buffer of bytes is now tiny, and you can grab everything you need in one go and just place them into the off-screen buffer. Steve sent me some demo code, and in that demo code, he used this as the buffer of graphics bytes for the gravel. And you'll see, rather than the kind of gravel I've been using, he's just using these multicolored stripes, which actually is nice. It helps to make it clear as you run it, the scrolling that you get. So the idea is you grab 8 bytes, let's say these 8 bytes, and you just blast them 4 times onto the ground. Next time around, you grab these 8 bytes, you blast them onto the ground. Then you grab these 8 bytes and you blast them 4 times onto the ground. Since I'm doing double buffering, it's a bit more complicated than that, but that's the general idea. And I did have to make some adjustments to the code to work in my current code base, particularly to work with double buffering. As a result, some of the nifty tricks that Steve was using I couldn't use. For example, the pointer into the source bytes of the gravel where you copy from, he was updating that with self-modifying code. I couldn't do that unless every time I swapped buffers, I rewrote the pointer. That would have undone much of the gains of self-modifying code, though not necessarily all the gains. But to keep things simple, I got rid of that particular part of the self-modifying code. So what I have now takes the stack pointer as it is and tucks it away using self-modifying code as I did in the previous example. I grab my pointer into the gravel, the source bytes. I update it by 2. Since I have alternating off-screen buffers and each one needs to go up from 1 from the last buffer, each buffer goes up from 2 from the last time that same buffer had to render the gravel. I check if I need to wrap around. If not, I skip. If so, this is how I do it. And again, this is also slower than what Steve did. He was able to just use immediate addressing to reload U at the very beginning of the buffer. Since I have these 2 off-screen buffers that are staggered with respect to each other, I won't necessarily be resetting to the very beginning of the gravel source bytes. I might need to be resetting to offset 1 of the gravel source bytes. Either way, decreasing by 8 will reset me to the appropriate offset into the source bytes. I then store my updated gravel pointer back into memory, and here is the heart of the idea. With one pull, I grab 8 bytes of gravel data from wherever the gravel source bytes are. I can then reuse U to be my destination register because I've already grabbed everything I needed with a single pull. So now I redirect U to point to the very end of where the gravel needs to be rendered in the off-screen buffer. And I got 4 pushes of 8 bytes each. So I'm repeating the same 4 bytes over and over and over again. The only question here is whether this is going to look natural like it did before, because I had a full, actually I had more than 32 bytes before. When I'm done with that, I restore the stack pointer and I'm done. That's it, that's the whole thing. So first let's take a look at what it looked like with these colored stripes on the ground. Well, it works. In fact, I kind of like the striped look. I don't think I'm going to keep it, but it's nice to see something different for a change. The real question, though, is how natural is this going to look when I put gravel back in? Is it going to be noticeable that it's repeating? So in lieu of these bytes, we'll use these bytes. So I took these directly from my gravel data. And since I only need 15 bytes by using this scheme, this will save me some memory. So what do you think? How obvious is it that it's repeating? I think if you know to look for it, you can see it. But if I hadn't told you what I was doing, would you have noticed? I honestly, I don't know that I would have noticed. I actually think this looks pretty good. So if I get the cycle savings I'm hoping to get with this may well be the way that I go. So what do I save? As a reminder, the current reigning champion is 208 cycles. That's the number to beat. What are we gonna get? And keep in mind, I could probably... Holy cow! Holy cow! 137? Holy cow! Boy, you save a lot when you skimp on graphics. Dang! And I was gonna say there are other areas of the code I can probably speed up, such as initialization and tracking the gravel pointers and stuff. I haven't even changed some of that stuff, and probably much of it can be removed. And Steve also sent me a follow-up message with a couple more ideas of things that could be sped up a bit. Woo! I think we have a new champion. Well, that covers the revisiting of the gravel. I think we're plenty fast enough until I get yet another message, I suppose, of someone who has yet another idea. A very special thanks to those who took the time out to write messages and to come up with their own versions of the code. And of course, thanks to everybody else for watching.